Hello everyone, this is Jahangir Alam. I'm going to present our paper SocialGuard, which is Bangla text-based gender identification for enhancing integrity in social networks. Let's look into the motivation for this work. Um Nowadays in social network, the fake users, the adversary users tries to create fake accounts and they try to engage with other normal authentic users and they do some adversary thing, they do some fraudulent activities. Um, when fake users communicate through the textual data, they they try to pretend like female or pretend like male, whereas they're actually in different gender. So we try to detect the gender from the textual data, um, which uh, which will solve the which can solve the fraudulent activity in social network. Another motivation is this problem has been studied extensively in other languages, which are English, Arabic, and Russian language. But in Bangla language, the problem is yet to be explored extensively. Um, uh, as per our knowledge, we are the first to explore the gender identification from Bangla textual data. So this is our motivation. If we formulate the problem, so it would be for a given text, can we identify if a author is a man or women using the machine learning and deep learning models. We design a system architecture where there are multiple modules, which are post trigger module, gender prediction module, gender validation module, and UI module. The post trigger module is triggered whenever a user posts a status in the social network, and the gender prediction module analyze the text from the post, and it predicts the gender from the post, doing some predictive uh, predictive operations. So in the gender validation module, it collects the user demographic information from the user account, which are publicly available, and it gets the predicted gender from the gender prediction module, and it cross validate the predicted and the actual gender, and um, it and the UI module shows the match or mismatch between the predicted and the actual gender. So this is how our prototype shows the predicted and the actual user gender, which is available publicly in the user account. So whenever other normal authentic user will come across the user post, they will see this information and um, will be alert about the fraudulent activity. In methodology, we perform different steps. First, we do the data collection. In data collection, we perform several steps. We collect user posts from Facebook groups, pages, and individual profiles, which are publicly available. We implement a Python-based Selenium script to collect these data. We perform the data pre-processing on the collected data, um, and we store the data in CSV format. We collect 9,200 male data and 5,800 female data, which is in total 1,500 data. In data pre-processing step, we perform several pre-processing, which are removing non-alphanumeric characters, removing punctuation and URL, removing stop words, and finally tokenizing the user post. Then we perform the feature extraction methods. We perform three different feature extraction methods, which are stylometric feature approach, TF-IDF feature approach, and word embedding feature approach. Let's look into detail on the stylometric feature approach. In stylometric feature approach, we perform five different types of feature extraction, which are character-based feature, word-based lexical features, syntactic features, structural features, and functional words features. In character-based features, we calculate different features, which are number of total characters, total number of digits, total number of white space, total number of tab space, total number of elongation characters, total number of dependent vowel characters, total number of spatial characters. From For each of these feature category, there are several feature which generate multiple values. So we are not showing the detail of these values here. So the character-based feature reflects the stylistic characteristics of the user and the readability of the user post. In word-based feature, we calculate the total number of words, average word length. We calculate total number of unique words, total number of short words, total number of long words, word length frequency distribution, total number of consecutive occurrence. Um, Similarly, in each of these features, some of the feature can generate multiple values, and the word-based feature reflects the language assessment. It reflects the first and second language acquisition, um, and in syntactic feature, we calculate the total number of single quotes, total number of comma, total number of periods, total number of colons, semicolons, question marks, and exclamation marks. These syntactic features reflects the writing formation patterns of the author. In structural feature, we calculate the total number of lines, total number of paragraphs, total number of sentence, total number of blank lines, total number of non-blank lines, total length of non-blank lines, and the average number of character per paragraph. The structural feature reflects the organization of the layout of a text by an author. It also reflects the different habitual fits of an author, so which is important to get information about the author gender for a given text. In content specific feature, we calculate some set of phrases which are economic phrase, policy phrase, social phrase, and sports phrase. In each of these phrase category, there are several. There are sets of phrases which are in different from each of these feature set, uh, which are related to these categories, like their uh, economic phrase related to the economy, policy phrases related to the policy making, related social phrases related to the social terms, and the sports phrases related to the sports. These features reflects the author's writing pattern formation. For each of these feature category, there are several value generated from each of the post. In total, we calculate 141 features in stylometric feature approach. We also experiment using the TF-IDF and word embedding feature approach. In TF-IDF, we use the n-gram parameter value as 2. We use the max feature value as 1000. In word embedding feature approach, we use the word to bake model from the GenSim library. We use 300 as the embedding dimension. We use the sigmoid activation function. We use the RMS prop as the optimizer, cross entropy as the loss function. We experiment using different machine learning and deep learning model. From the machine learning model, we experiment using the naive Bayes upper vector machine, logistic regression, decision tree, random forest, stochastic gradient descent, and k-nearest neighbor. From the deep learning models, we experiment using the MLP, LSTM, and GRU model. We compare the performance of the machine learning and deep learning model. We observe the traditional machine learning models outperforms the deep learning models when we use the TF-IDF feature approach. Let's look into the model architecture. For the stylometric feature approach, the architecture shows we pass the data in the feature extraction module, which extract character-based, word-based, syntactic, content-specific, and structural features from each of the text, which is 141 features, and then we pass the feature vector to the models, and finally we get the classification result, which is the gender of the text. In TF-IDF feature approach, we pass the data through the pre-processing step. Um, we perform some pre-processing, which is tokenization, punctuation removal, stop word removal, and we pass it to the TF-IDF feature extraction module, which is where we use the TF-IDF vectorizer to get the feature vector, and then we pass it to the models, the machine learning and deep learning models, and finally the model gives us the classified gender for the given text. In word embedding feature approach, we perform the pre-processing similarly, and we calculate the embedding matrix for the given text, and we pass it to the MLP LSTM GRU models, and in the output layer, we get oh, the classification result, which is the gender of the given text. We observe the traditional machine learning model SGD performs the best when we use the TF-IDF feature approach. It achieves the accuracy of 78.33% and a F1 score of 87.67%. It performs better than the word embedding and stylometric feature when used the TF-IDF feature approach. We calculate the ROC curve for each of the model. Here is the ROC curve of each of the model. Here is the comprehensive result, the accuracy and F1 score for each of the feature approach, which are stylometric, TF-IDF, and word embedding. The SGD performs the best, which is highlighted in this slide. We perform the system evaluation. We perform the evaluation of the best performing model, which is SGD, using the real world data from the collected from the social media, and we perform the sensitivity analysis of the model using noisy data. If we look into the real world experiment, which is we collect 1270 male data and 1430 female data randomly from the social network, which is from the Facebook, and we perform the evaluation of the SGD model with this data. Before that, we label the data with the actual male and female uh, during the collection process. We perform the experiment for uh, different word count, and that means different length of the post. So we perform for word count 20, 30, 40, 60, up to 100. So we observe the highest accuracy of 63.21% and F1 score of 76.80%. and the average accuracy of 60.96%, and the average F1 score of 75.35%. Um, in the sensitivity analysis, what we do, we mix the female data with the male data, and we mix the male data with the female data to create the noisy data. So in the x-axis, we see the percentage of noise, which is 5, 10, 15, 20, up to 45. So um, in a text with length of 100, we replace 5 word with female word with words from female post, and we replace 10 words of a male post with the 10 words from the female post. And similarly for the 1520, we replace this number of words from the male post with the similar number of words from the female post. And vice versa, we do the same for the female post to create noisy data. So what we observe the decreasing accuracy with the percentage increase of the noise, and decreasing F1 score with the increase of noise percentage. So after around 30% of mixing, we see the too much decrease in accuracy and F1 score. So we can say, after the 30% mixture of noise, our model can perform drastically bad in the sensitivity analysis. So in this robustness test, we can say after 30% noise addition, it performs the worst. So the gender identification is crucial for preventing fraudulent activities in online social networks during the textual communication. So in this work, we faced the challenge for data diversity and computational resources, and um, we could collect data from the sources which are publicly available. That means the publicly available user post, publicly available groups and pages, and we could collect only 15,000 data, which is not too much data for deep learning models to train well. So we can summary, like we perform this experimentation, which is a significant addition in Bangla gender identification problem, and in future we can improve in several direction. Like we can expand the data set, we can try to improve the performance of the deep learning model. We can collect data from other social media platforms. We can experiment using the latest models, which are BARD based models and large language models. Hopefully, we can improve the performance and accuracy in this gender identification, performing these future directions. Thank you. That's all.